We are Team Phlegra Prime, and this is our submission for the 2020 Mars City-State Design Competition. Our team consists of Robbie Gittin from Blue Origin, Suya Tangnu, an architect and BIM engineer, Ben Greaves, a high seas analog astronaut, me, Michael Barrett of Fraunhofer USA and Ascent LLC, and Zach Tolley from Blue Origin. Our vision for Phlegra Prime actually begins with our population model as it forms the timeline of our design. We made two assumptions: that the birth and death rates are comparable to those in the developed world, and that the progress in space travel is slow, about 1/3 of the growth rate in air travel during the 20th century. Putting this together, we find that it will take about 250 years for the population of Mars to reach 1 million people. Finding investors to fund a project that requires centuries to reach fruition is impossible, as any investor would not live to see a return. This means that any Mars colony must be profitable in the short term. In order to grow Phlegra Prime, the physical and intellectual capital of its citizens needs to be reinvested in the city. Finally, we wanted a system that encourages firms to invest in the training and well-being of their employees. We wanted to select our immigrants not for their education or capital, but to ensure that they have similar demographics to the population of Earth, including race, gender identity, skill, political inclination, and disabilities. Immigrants should not spend a fortune to travel to Phlegra Prime. Instead, they will go to Phlegra Prime to make their fortune. We have the industrial technology able to sustain extended life on another planet today. And though we can expect an immense amount of innovation to occur in the next few hundred years, we designed our city with modern day technology in mind. And it was our conclusion that a Mars colony is possible without as yet unrefined technologies such as artificial intelligence or fusion power. To make Phlegra Prime an enjoyable place to live, we decided that the city needed to have places to connect with nature and animals, both wild and domestic. We wanted to leverage our prioritization of diversity to create a heterogeneous series of cultural districts, allowing each citizen to visit and experience cultures completely different from their own. The goal of this report is not to provide a meticulously detailed multi-century plan, but to design the anthropological conditions under which a Mars colony would be successful. We will be describing how a small initial settlement of around 100 colonists will progress organically in government, economy, and culture to a final city-state which is not only able to support 1 million colonists, but remain peaceful and stable for centuries to come.
Thank you, Mikey. Good evening, everyone. My name is Suya. I will be presenting Phlegra Prime's master plan and experience for its citizens. So foremost, we set out to choose a site for a city-state. Considering various factors, we zeroed in on Phlegra Montes, located in the northern hemisphere in the region of Arcadia Planitia. This location has access to abundant shallow ice in the north that can be mined for water for the production of oxygen and rocket propellant. It is also located at a relatively low latitude, so atmospheric temperatures would be warmer than at the poles and would also receive ample solar energy. This region has diverse topography with vast expanses of flat areas that make for favorable landing sites. There is also proximity to ridges and thrust fault structures that suggest a diversity of materials will be found. The city-state for 1 million people is planned as a group of discrete districts with capacities for about 80,000 to 120,000 citizens each. This method of decentralization gives us an opportunity to create diverse economic and social functions for each district. The economic functions would be space travel, food production, mining, administration, and others, while the social functions can be museums, convention centers, theaters, fine dining venues, and such. These functions would encourage the state's citizens to move across districts for both economic and recreational reasons, creating opportunities for business and social interactions. Citizens will have the freedom to live in any district that they prefer. To fuel these exchanges among the districts in a seamless manner, these districts would be connected by high-speed mass transit systems. It will consist of trains that pass through vacuum-sealed tunnels between the target district. Every district has residences, education facilities, primary healthcare, retail, and multi-spiritual centers. Every district will have its own utility systems, such as air treatment, water recycling, solar farms, waste management, as well as primary agriculture. A district would be able to sustain itself for a few weeks in case the links to other cities are disrupted temporarily. Each district's location would be chosen by geographic proximity to its economic or social functions. These districts will be built sequentially in phases as the state's population increases over the years. Each district built over time will be different in architectural expression. They will further be guided by the geographic context and the economic function, while also being influenced by the evolution of the construction capabilities during the course of habitation. Here is an example, our rendering of a district that houses the spaceport functions. It will be among the first to take place. Hence, a part of the district would have structures that were brought from Earth and would consist of discrete volumes connected by pressurized tubes and tunnels. On the other hand, the districts built thereafter will have more evolved construction capabilities, including larger spans and more open spaces that feel like the outdoors on the Earth. As these districts grow in size, it is expected that they will develop sophisticated and differentiated cultures. This model of decentralized districts is easily scalable and replicable. The districts are further made up of neighborhoods that house about 5,000 to 10,000 citizens each. Each of the neighborhoods will have a unifying architectural style. The planners can choose to bring in style from the Earth or create entirely new ones. Each district would have community kitchens, clinics, recreation centers, spaces for small business and retail. The size of the neighborhoods is such that all amenities will be within walkable distances. Within this district, the transportation of people and materials will be done by below-ground rail systems and autonomous pods. These pods will be maintained by the city-state government and can be reserved by every citizen through the internet. The pods will have digital assistants to help the differently abled and the minors, empowering every citizen to move freely and independently. When a citizen wishes to travel to a different district, these pods will load onto the inter-district train and reach the target district. The district citizens can enjoy libraries, opera, movie theaters, art history museums, artificial beaches, shopping, restaurants, and nightclubs. They can take a walk through the green domes that nurture plant and animal life. The ecosystems will allow for each district to simulate Earth-like climates. Personal entertainment, such as books, movies, video games, will be transmitted from Earth. The citizens and tourists will have guided expedition outside these districts to the Martian surface to experience the wilderness and appreciate their local environment. Most structures will be a combination of subterranean and superstructures. The subterranean spaces will be naturally shielded from radiation, while the space above ground will be enclosed with radiation shielding materials. They would use excavated Mars regolith, masonry blocks made of regolith, sulfur concrete, polyethylene, or ice. The subterranean and superstructures would also be enclosed in temperature shielding layers, such as glass, vacuum, operable shutters that can protect from radiation. The common and circulation spaces will aim to have high ceilings and longer open spans to alleviate the sense of claustrophobia. Each pressurized space will have a radiation rating. Localized dosimeters will be used to calculate and track the radiation that each citizen is exposed to. If an individual exceeds their exposure limit, the system will notify the citizen and their healthcare practitioner to make changes to their routine and reduce future exposure. Passing the mic to Robbie to tell you more about Phlegra Prime.
Thank you, Suya. Hello, my name is Robbie Giddin, and I'm going to talk about the long pole in the tent with Mars settlement, which is the economic case. We wanted to show that developing Phlegra Prime is viable, even under pragmatic and conservative assumptions. Our vision for Phlegra Prime is not prescriptive in what the killer app for Mars is, but instead tries to lay out conditions under which growth will happen. Our market evaluation for establishing the Phlegra Prime settlement hinges on the assumptions that Starship works as advertised and that mass can be transported to Mars for $500 a kilogram. For a 90-kilogram average human, this roughly translates to $63,000 for a round-trip ticket. This is comparable to the price of transportation to Earth's extreme polar regions, the high Arctic and the Antarctic. If you made no additional assumptions about speculative space industries such as helium-3 or asteroid mining, then it would be reasonable to say that whatever the economy can support at the poles today, it could support at Mars with this low cost of transportation. We looked at the total economic turnover in the Antarctic and on Svalbard, a permanent human settlement in the high Arctic. The first thing to notice is that both of these polar frontiers are operated as public-private partnerships, with a large government subsidy, either in the form of indirect funding for research or direct funding for infrastructure. The second thing to point out is that the existence of Antarctica does not crowd out the market for Svalbard. People still want to go to both. Mars has many unique geographic regions for scientific exploration and adventure, so we believe that the total market evaluation for these activities on Mars would be much larger as well. However, in the interest of being pragmatic, we will say that at a minimum, the near-term Martian market evaluation is equivalent to these two polar locations combined. We can now say some things about the profitability of Mars settlement. Making some modest assumptions on habitation technology, the logistics cost for operating an initial 100-person settlement could be as low as $9 million per launch window. Making some further assumptions at the interest rates and payback period, we find the business case for establishing Phlegra Prime closes if the total cost of development is below $63 billion. This is within the range of historic large-scale aerospace programs such as ISS or Apollo, and it could easily be funded by governments, consortiums of governments, or wealthy individuals. Here is one of many scenarios for how the economy of Phlegra Prime would evolve. Using the Antarctic and Svalbard as our model, the early days of the settlement will be heavily oriented towards research and adventure tourism. We want Phlegra Prime to attract scientists from every major university and adventurers from around the world. As the outpost population grows, one could imagine that a small retail and services industry would develop to accommodate the growing population. This would inevitably lead to light manufacturing to support the local economy and heavy industry as the settlement became more self-sufficient. I want you to think for a moment about what an advanced industrial economy of 1 million people looks like. We are talking about a city the size of Dallas, Texas, or Naples, Italy. Although we cannot say much about what the economy is doing, we can say that we want an economy that enables entrepreneurship, dynamism, and growth. We also want to avoid social stressors like high unemployment and economic inequality, which will be amplified by the close quarters nature of Martian living. To meet these desires, we propose a hybrid cooperative corporate structure and a strong Bill of Rights to protect liberty and property, which we will discuss later. This cooperative corporate structure was pioneered over the past 60 years by the Mondragon Group, one of the largest industrial corporations in Spain. On the surface, a company on Phlegra Prime looks and functions like a modern corporation, but with three main differences. The first is that all employees, with the exception of the founders, are equal owners of the venture and have some voting power. The second is that the company sets a maximum salary ratio between the highest and lowest paid employee. Mondragon typically sets this at 10 to 1 or 20 to 1, with the goal being to reduce economic inequality in the workforce. The third is that about half the profits are shared amongst the employee owners, providing an incentive for everyone to make the business succeed. The remaining half is reinvested in the company in the form of capital improvements, retraining, and R&D. The goal of this system is to continuously reinvest money in the Martian economy and drive growth instead of lining the pockets of shareholders back on Earth. The commercial co-ops will be part of a larger ecosystem of cooperative ventures providing financial services and higher level education. The goal is that by continuously reinvesting profits into the economy, the co-ops can organically provide many of the services that would otherwise be provided via state welfare. The system also incentivizes the creation of new businesses in that people who found new ventures are allowed to participate in their corporations with twice the equity of those who join at a later date. I'll now hand it off to Zach to talk about the industrialization process.
Thanks, Robbie. Just as we have tried to take the tact of understanding our population economic growth model to set up the conditions for a successful city without prescribing exactly how it would develop both either economically or technically, we've endeavored to take a technical approach that allows for bootstrapping from a relatively small set of initial manufacturing capabilities to full industrial self-sufficiency. We'll take a spiral development approach with each spiral focusing on bringing in a higher order of raw materials to the economy of the city. Spiral 1 will focus on raw materials known to be ubiquitous on Mars. Spiral 2 will focus on resources that we believe are on Mars but require a concerted effort to mine. And Spiral 3 on exquisite created resources. The first payloads landed at the city site will be a seed factory to provide an initial manufacturing capability that will be able to replicate itself close to 80% by mass. With that initial 50 to 100 tons of landed mass, every additional conjunction opportunity for imported capabilities will be able to leverage a 5-to-1 advantage on a mass basis. That seed capability will use ice, the Martian atmosphere, and regolith to provide feedstocks for metal additive manufacturing and conventional milling, produce engineering polymers and perhaps simple composites, and sulfur concrete for civil engineering work. The chemical processes and manufacturing technologies that we envision as being utilized in the seed factory are well understood and deployed terrestrially. Material processing to produce these feedstocks for manufacturing will also provide significant life support consumables for the nascent colony. After many conjunction opportunities and many doublings of the basic industrial output of the colony, the primary focus of development will shift from expanding basic industrial capacity to adding new capabilities, and Spiral 2 will begin. Spiral 2 will focus on identifying local sources of strategic resources like copper, rare earths, and ilmenite for titanium production. With the addition of these materials, more advanced manufacturing will be undertaken, such as producing electric motors, turbo machinery, and simple electronics. At this juncture, silicon production will begin, both for the production of optical quality glasses and sensors, as well as pure silicon wafers to support the semiconductor industry to come. In this era, the colony will begin to mine thorium, which is known to exist on the Martian surface. When combined with initially imported uranium starter fuel, a thorium fuel cycle built around the breeding of uranium-233 will begin, which will allow the colony to become energy rich. If uranium is found, we'll build enrichment plants. Uranium-235 is especially suitable for mobile power and propulsion applications, and uranium export for space uses may actually be a significant source of revenue for the colony, as it would sidestep the regulatory burdens associated with licensing and launch from Earth, as well as potentially be a method around the arbitrary levels of enrichment that cap the use of fissile fuels in commercial applications on Earth. At a certain juncture, the import of even low mass precision materials will become unacceptable to the colony, and Spiral 3 will begin. This will be the final drive to industrial self-sufficiency. Just as America still trades with Europe, it is unlikely that the importation of certain highly specialized products will ever cease. But for a colony to be truly self-sufficient, it needs to be able to organically produce microprocessors, memory, and pharmaceuticals. That will be the objective of Spiral 3. Transitioning from how we will build the colony to what we will build, the power system is foundational to the existence of a city on Mars. In keeping with our objective of designing a million-person city that is scalable, we envision a power system in which each district is self-sufficient in power, fed by its own reactor complex, with secondary solar power, supplemented by mobile reactors which will be used to facilitate mining and other remote endeavors. Each district power system will be sized to produce approximately 50% more power than is required at its peak demand, and will be cross-connected by a smart high-voltage grid through power lines to adjacent districts. This distributed power architecture allows both a trade in power between districts, as well as fault tolerance, allowing each district to remain powered even during planned power system maintenance activities or accidents or unfortunate natural disaster. That power will, of course, be used by the integrated life support and agriculture system. Habitat internal temperature will be regulated using waste heat from the reactor complex, which will be leveraged in the circulation of heated water throughout the colony to provide a base level of heating. Atmospheric revitalization will take place through both distributed physiochemical means, as well as through modular water walls placed throughout the colony that will use algal beds to absorb CO2 and provide oxygen regeneration. Algae will also can be processed into animal feed or a nutrient slurry for hydroponics. Bulk calories will come from high-density automated vertical hydroponic farms that utilize tailored gas and lighting spectrum to maximize plant growth. Plant waste in such facilities will be used synergistically to raise both fish and poultry. And individual residences will be provided by a space for gardens, so those who are so inclined, which is to say not me, have the ability to grow specialty fruits, herbs, or flowers. Meat will most likely initially be lab grown or additively produced, but conventional animal husbandry will be introduced as soon as the volumes necessary become economically available. By the time our city reaches 1 million people, it will be self-sufficient from steaks to microprocessors. It must be able to govern itself, and to discuss that concept of government, I'll turn it over to Ben Greaves.
Thank you so much. In order for a fragile Martian city-state to be successful, it is critically important to avoid civil unrest. For this reason, we gave acute attention to a political system that empowers citizens, allows everyone's voice to be heard, and enshrines individual rights above all else through establishing a Bill of Rights.
5 minutes to Q&A.
Thank you so much. Citizens' rights will be extended to anyone who establishes residency within the city-state. When selecting immigrants from Earth, Phlegra Prime will strive for a demographic makeup that evenly represents Earth's population from natural origin, race, color, religion, sex, physical or mental disability, and age. The government of Phlegra Prime will be divided into 3 levels, from left to right, neighborhood, district, and city-state. Each neighborhood will have elected officials that organize community education, policing, emergency services, as well as maintain local infrastructure. Each district will have their own level of government handling issues within the district overall, including overall zoning and municipal infrastructure such as transportation and utilities. Finally, the city-state government, representing all of Phlegra Prime, creates laws for commerce and human rights, conducts foreign policies, and administers inter-district relations. Like many terrestrial governments, Phlegra Primes will consist of 3 branches: an executive, legislative, and judiciary branch with separation of powers and checks and balances. This 3-branch system is where the similarities end. Perhaps the biggest departure from the current terrestrial governments is the legislature. Instead of selecting representatives by voting, representatives will be selected by lottery. This policy has many exciting advantages, such as subversion from partisanship, elimination of political campaigning, the fostering of strong civic virtue in the public, and finally, better representation of the city-state population. The knowledge that anyone on the street could at any time be randomly called upon to serve in the settlement's highest office will incentivize citizens to both take an interest in political affairs and to think about how policy directly impacts the people around them. This idea was even encouraged by Malcolm Gladwell in a recent talk with Big Think. Once the city-state reaches 1 million people, this legislative branch will be made up of 1,200 citizens, on a cycle of 400 people being selected each year, as that would statistically represent 1 million people with a 95% confidence level. The legislative branch will be made up of 3 houses. As you can see, agenda council, review panels, and a policy jury. Next, the executive will be led by a 4-person executive council who collectively serve as the heads of state. Each member will serve as a single 4-year term and is elected on a rotating basis each year by the agenda council. All decisions by the executive council will be unanimous. Finally, the judiciary will be divided between 3 different levels of authority. Again, from left to right, the majority of crimes committed will be relatively minor, hopefully, and will be handled by a neighborhood tribunal where jurors are elected by their neighborhood. Improperly handled local cases may be appealed to a higher court where judges will be elected by citizens of the entire district. The highest court, the Human Rights Court, will serve to both consider the appeals from lower courts and will review every law passed by the Agenda Council. Judges for this court will be nominated by the Executive Council and be approved by the Agenda Council with a 2/3 majority. Next, the Phlegra Prime has no standing military, but a period of civilian service after the completion of school will be highly encouraged. This civilian service will allow individuals to experience work in the context of being part of the essential services of the city-state. These civil servants may work in healthcare, maintain infrastructure such as food production and life support, or even assist with the construction of buildings. This means all citizens will work to maintain Phlegra Prime and work on the diverse city-state population. Education. The Phlegra Prime school system is based on an international model, allowing both students and parents from around Earth to effectively integrate into the new educational system. Our population model predicts that there will be just over 164,000 students in the ISCED levels 0 through 3, which is younger than university level, and around 56,000 students levels 4 through 8, which is universities, undergraduate, and graduate levels. Levels 4 through 8 will consist of many universities of around 5,000 students each, with each university having specialized focus on topics such as arts, technology, science, construction, and humanities. Remote university enrollment from students on Earth will also be a huge method of financial income for Phlegra Prime. With thorough analysis of each student's pace and ability to learn topics, curriculum will be tailored to a student's individual learning styles and needs. This will replace conventional teaching strategies with a system more similar to the online learning of today. Only a handful of staff members will therefore be able to facilitate the education of hundreds of students, stepping in only when there's an issue with the learning tool. I'll finally pass it off to Mikey to finish this off.
Phlegra Prime was designed to be a more equitable and just society than any currently implemented, while sustaining life in a hostile environment and ensuring its citizens live with not only the pursuit of happiness, but a guarantee of a comfortable and fulfilling life. No place on this planet is far enough removed from the institutional problems of today to be truly free from their influence. Phlegra Prime is our chance to create a better home than any found on Earth. Thank you for listening to our presentation.
5 minutes for Q&A.
Great timing.
Manosis, you can go.
Thank you, teammates. My question is, what are the provisions of changes to the political system, as to bring a continuous improvement and progression to possible perfection at every given time? Thank you.
Thank you. Excellent question. So when we began this process, we actually talked to several anthropologists who study both spacecraft group dynamics and closed societies. And what we were trying to avoid was a scenario where living in a space habitat, the chance for any sort of social tension to explode catastrophically is incredibly high. It's a very fragile environment. A riot, an unrest could damage things and kill almost everyone. So what the anthropologists feared was that in order to keep people safe, space settlement societies would naturally find themselves being drawn to extreme forms of coercion and social control. So in the structure of the government, in the structure of the economy, we tried to make systems that allow these tensions to be resolved at every level, and most importantly, make people feel like they have ownership in their political process and in their economic life.
George?
Thank you. Very nice presentation. So you've specified that all the decisions by the 4-member executive council should be unanimous. Do you have a reference of this working out nicely in a country here on Earth?
I could not name you the specific country, but there are countries where the executive is a panel of people. And I could be happy to provide you that reference offline.
The unanimity is the question here. I'm a bit concerned about the unanimity.
Sure. The idea being that it forces compromise at a very high level in the execution of policy, and that it prevents the executive branch from exploding in power, as many executive branches have done on Earth today, by making it hard for the executive branch, hard on purpose for it to enact policy.
Yeah, thank you.
Sean?
You had talked about not having a military at all. Would you be talking about having a police force that is a little bit stronger, or what would your thoughts be on civil unrest?
Yes, so we would certainly have a level of police force, and this would be more towards the level of not necessarily as weaponized as some police forces today, but the idea would be to be able to conduct these methods as controlled as possible. In terms of the military force, this was obviously there are not many citizens amongst our city-state, and so making sure that we don't really expect any sort of external threats in the form of military aggressors to really be a problem. If that is the case, we have much larger problems.
Yeah, and just to chime in and expand on that, if there was a credible external threat, the system could adapt to hosting a military. We just don't see one as being required at this, at the million-person level of development.
We've got about a minute left. Are there any other questions? Manuel?
Hi, yeah. So just for this last minute, I think you guys have done a good job dealing with economic, technical, and sociocultural aspects, but I feel you have not touched upon aesthetics, design, culture, and related matters. So perhaps could you spend the rest of this minute talking about the aesthetic aspect of your proposal?
Yeah, I can take that question. We wanted to show something that can be possible in the next decade.
Sorry, time's up. Sorry, time's up. All right, thank you very much, Phlegra Prime.